Okay, so let's start. So this is GATE 2022 Life Sciences, section S, Chemistry, question number 11. Consider a second order reaction where 2A gives product. The concentration of A is represented as A in square brackets. Which of the following is the correct plot for determining the rate constant for the above reaction? And this is the NPTEL online course reference for the question. Okay, so we'll first try and understand basics of the rate of reaction. Okay, so let's consider a reaction, a simple reaction. So in the question we have, what do we have in the question? We have a second order reaction, right? We have a second order reaction here where the 2A is the reactants which is giving us product. So we'll consider this reaction as the example. So we have 2A giving us product P. Okay, this is the reaction in the question, and this is a second order reaction. Okay, why this is a second order reaction? Because the formation of P product depends upon the reactant A. Okay, and this reactant A has a order 2. Okay, so this is a second order reaction. So another example of a second order reaction could be A plus B is giving you a product. This is also a second order reaction. So the order of reaction, the formula is very simple. Order of reaction, it is what? It is the, so the order of reaction is nothing but the number of reactants. So here it will be A and B, number of reactants involved. So the order of reaction will be A plus B. Here we have only one reactant, so the order here is 2. Here also the order will be, here also the order will be A plus B, and here there is already a 2 times the reactant, so the order also will be 2. Okay, and this A could be anything. This A could be 3, B could be 2, so the order will become 5. It will be a 5 order reaction for this. Whereas in our example we have 2A giving us product, so the order is 2. So very simple, this is a second order reaction, right? This is a second order reaction. Okay, so when we draw a graph for this, if we draw a graph, okay, so on x-axis we have time, and on y-axis we have concentration. Okay, we have concentration in general, and there are two graphs. So this is the graph for the formation of product P. Okay, and this is a graph for the reduction of a reactant A. Okay, so as you can see, as the time course, along the time course, what will happen? The product formation will go on increase, and the concentration of reactant will go on decreasing. This is very straightforward. Okay, this is the reaction profile of this biochemical reaction. Okay, so what is the rate of a reaction? Rate of a reaction is pretty simple. Rate of reaction by formula, it is given by difference in the concentration upon time, right? Rate is nothing but anything which says rate, it will have a denominator time. So difference in the concentration in upon time is the rate. Okay, So rate will be difference in the concentration of the rate will be difference in the concentration of reactant. So this will be negative because the reactant, the A reactant is decreasing. That's why we'll have a rate of reactant. It will depend upon the reactants and there will be a negative sign. Why? Because the reactant concentration is decreasing over the time. And this 1/2 denotes the 2 here. Okay, it will go in the denominator, right? So here also how the rate will be, it will be minus 1/A. Our rate will be minus 1/A, difference in the concentration, and this difference in the concentration can be denoted by delta, right? Delta, and a small difference can be also be denoted as a small d. Okay, a small d can be also be denoted, or a delta. Apart from this, we also know rate is directly proportional, right? Rate is directly proportional to the reactants raised to the power 2, and concentration of rate is directly proportional to the concentration of reactants. Okay, these are the two rate laws which we know, right? So the first rate is also equal to the change in concentration of product upon time. Okay, I forgot to write dt here, or delta t. So rate is change in concentration of product of time. Also rate is directly proportional to the concentration of reactants, and here there are 2 times the reactant, so it will become square. Okay, so so it is pretty clear that the rate of reaction will be depend upon the concentration of reactants. So the reactant which is present in the initial reaction will determine the rate of a reaction, right? It is pretty straightforward. If we have more amount of initial reactants, we'll get more amount of product, and also the rate will be high. So rate is directly proportional to the reactants. Okay, and when we remove this proportionality, we'll get rate constant, which is denoted by small k. Yeah, this is very straightforward. So we now have 2 rate terms, this, and we have this rate term, okay, with us. So now in the question they have asked us to plot a linear plot. So okay, so let's consider, so let's, if we can equate this, so if we can equate this, what we'll get, we'll have minus dA by dt, this minus dA by dt is equal to k, small k, so these are the so the rate, so we have two rate formulas. One is differential rate law and one is the rate constant, definition of the rate constant. We have these two equation, so we are equating these two equation. Okay, they both help us to find out the rate of a reaction. So when we equate these two equation, so when we use this term delta, suppose we consider this reaction of P, when we are considering only a small instantaneous reaction. Okay, small instantaneous reaction. That is why we consider a term delta. Delta is very small instantaneous change in A, very small change at very small time. Okay, so if we want to know if we want to understand the rate of a whole biochemical reaction over the period of time, what we'll do, so this is at this particular instant, but I want to know the rate of the whole formation of product. What I'll do, I'll integrate this equation. Okay, I'll integrate this equation. This is also very important. So when you integrate this equation, so this left hand side will integrate in terms of the reactant A, and the right hand side will integrate in terms of T. So now we'll take the like terms on one side. A square is equal to K dt. This is very simple. Okay, very simple, straightforward. Then what we'll do, we'll integrate this equation 3. Upon integrating, what we'll get, so we'll have some initial A0 and we'll have a final A. Okay, so here is the initial concentration of reactants. Okay, and this is the final concentration of reactant. Okay, so this is A0 and this is A. Okay, so by integrating, what we'll get, this is 1 by A square dA, so the minus term will be outside, dA is equal to K is a constant, integrating dt. Okay, and here also t is equal to 0 and there will be a time t. Okay, whatever the last time point will be, that will be t. These are the limits. Okay, these are the limits of a reaction. So the very initial limit is A0, final is A, concentration of reactant. Okay, and the T0 is the initial time and till time t, whichever will be the particular time. So what we'll get, so by integrating here, what we'll get, so this will be, so we have to integrate, and by integrating we'll get A raised to minus 1 at A0 and A, and here we'll have only a t term, right? Integration of dt, it will cancel each other out and we'll have a t term here. This will be T0 minus T1, right? Sorry, final minus T0, which is T only, because T0 is initial time, we will consider it as 1. So this will have T, and here we'll get, if we apply the limits, we'll get 1 by, why 1? Because this is raised to minus 1, so we'll get 1 by A, the final concentration, upon 1 by initial concentration is equal to KT. Okay, now we have to write this in terms of a linear equation. So what is the linear equation? Y is equal to mx plus c, right? This is a linear equation. This is the equation for the straight line, right? If we have a straight line, so this is the slope of that straight line m. M is the slope. This is the intercept c. C is the intercept. Okay, so this so the equation of this line is y is equal to mx plus c, and that is what we have to find out, and we have to write this particular equation in form of y is equal to mx plus c. Okay, so where m is our slope k. So if we write this in that form, what we'll get, 1 by concentration of A is equal to KT plus 1 by A0, right? This is in the form of y is equal to mx plus c, where m is equal to k. X axis is so the x axis we have t, right? Here also we have t. X will always be t. Y we have concentration of reactant, which is 1 by A, and C is the intercept, which is 1 by A0. Okay, so coming back to the question, what did we get? In the form of y is equal to mx plus c. So as you can see, all these are straight line. That's why we have to use a linear equation. This is the equation for the straight line. This is a straight line equation. And what did we get? On y-axis we have a, right? 1 by a. We got 1 by a is equal to kt plus 1 by a0, right? Which is matching this, right? So 1 by a is y is equal to m. So here the slope is k, rate constant, mx, x is time t, plus c, right? Y. So this intercept here, this is c, which is equal to 1 by A0, initial concentration. So this is the initial concentration, right? This is the initial concentration from which the reaction begins, right? So the correct answer is C. So we all must try to understand this. Okay, this is very important table. It displays various values and equations used for the basic chemical kinetics of 0, first and second order. You must always remember these 0, first and second order reaction. These are the various equations used. So this is the integrated rate law, which I derived it. So this is what I derived right now, right? This is what I derived. This is concentration of reactant at time t, y is equal to mx plus c, right? This is what we derived right now, second order. Similarly, we can derive for the first order. So here this was a second order. 2a is giving you a product p. A first order will be a giving you a product b. And this is a zero order, which doesn't depend on the reactant. Zero order reaction, it means it will not depend on the concentration of any reactant. Okay, that means it is a zero order reaction. So these are the integrated rate laws. Okay, you must remember this, or else try to derive these equations. Okay, similarly, you must always remember the rate constant, units of rate constant. This is also one of the frequent question asked in GATE. What is the unit of first order rate constant, zero order rate constant, and so on.